So, I'm Thierry. I'm from Ghent. Who's from Ghent? Yay! This was the lightning show from 2 years ago. There was one this weekend, if you managed to go. This one was better, though. Well, good. So, I want to make the case for non-blocking code reviews. It's a thing we did back in 2012 with a novice team, so it's quite a long time ago. We actually didn't realize this was actually a thing until last year, where Dave Farley picked up some of my tweets, and then one Sunday morning I was cooking, and then there is a message popping up on my phone, and you see a message from Dave Farley, and you're like, wow. And asking me like, oh, well, I really like your concept of non-blocking code reviews. Do you have an article to point me to? And there I was, shit, I've never written this down. Give me 5. Well, it took me a bit longer to write down the article, but I've never written an article that fast, so it took me a couple of hours, and next day, here you are, article, and so here I am. It's the first time I'm presenting this, so bear with me. Now, before we move on, I would like to first discuss, like, what do we want to achieve with code reviews? What is it that we want to obtain? What is the purpose of code reviews? And often, this is the first problem that teams face. They don't make a conscious decision about what they want to obtain from code reviews. And when they do, well, do they actually know what good design or bad design mean? How does it look like? So, before we start any work, well, we should clearly define this and state this so that we know what we are looking for. Now, back then, with that team, my reasons to introduce code reviews were, well, I wanted a mentoring tool. I wanted to be able to learn the team things, and I was hoping that if they see code from others, they would learn something. The other thing I wanted is to share knowledge. So because, yeah, the team was working on something like 20 applications, and so, well, to make sure knowledge about all of these applications was fluid, well, those code reviews helped. It also helped to check on readability and maintainability. So this is not about coding standards. For coding standards, we have tooling. We have linters, static code analysis. They are way better at doing that. So that avoids, well, so teams should define those coding standards up front before starting. And then it's the computer that says, well, it's okay or it's not. Computer says no. And it avoids like those unproductive discussions during code reviews, like spaces or tabs. Well, obviously it's spaces. Or curly braces at the end of the line or the new line. Well, or at the new line, please. Well, we agree, no? Right. It also helped to maintain consistency in design, although in hindsight, that was a mistake. Because, well, spotting design problems during code reviews, well, it's way too late. We've spent all this time creating this code, and then we see, oh no, it's not good. But that wasn't really a big deal, apart from wasting time, because we were practicing non-blocking code reviews. So, well, if we had bad designs, it didn't block the delivery. Features still went to users, and if we had to rewrite, well, we had the time to rewrite. Now, there are many other reasons people mention for having code reviews, and one of the most often mentioned, and that's specifically in regulated industries, is the 4 I's principle, which in my humble opinion is the killer argument to slow down teams and to eventually get a team to a halt with fairly little added value other than reassuring auditors that all checkboxes are ticked. So it's kind of quality theater. So the thing that we put in place to supposedly improve quality is actually doing the opposite. Research showed that. So there is a negative correlation between process gates and quality, so it drives down quality. Now, many times organizations conflate their interpretation of regulation with regulation, which is most of the time not the same thing. So most regulations asks, do you do what you say you do? And the most rigorous regulation, well, expect that two people look at the code and that we have an audit trail of what happened. So, in my humble opinion, the most effective way to implement 4 I's principles is through pair programming and team programming. And De Pauw reported that even in highly regulated industries like finance, like gambling industry, and even in healthcare, this is good enough to implement 4 I's. The other thing people mention is, well, it's to have a sense of security. Not true security, but a sense, an illusion of control. Or the other thing I hear a lot is, well, I don't trust my code. Now, many times there are absolutely valid reasons to feel like that. And this happens when we work with legacy code because we don't know what the code does. We have no idea if our changes broke the application or not. Or this happens in dysfunctional organization with lots of blame. So engineers want to protect themselves against that. And so they lean to others to look at the code so that they have more faith in their code. Now, in my opinion, I don't think any process can fix for that, and especially not code reviews. So this is a bigger problem. All right. Now, what code reviews should not be is an exercise of power. This happens quite easily when code reviews happen through tooling asynchronously. And while with that novice team we did that through tooling, and so while we need to be conscious about the way we communicate in a written way, because well, it's easy to misinterpret. So instead of that, well, we should do face-to-face synchronous code reviews. We should also avoid hierarchy in code reviews, so avoid that only team leads or seniors or architects are allowed to review. No, we should go to true peer reviews where everyone is equal. Code reviews should also not be assigned to untrained seniors who lack the mentoring skills and who lack the ability to communicate clearly and in a constructive way. I've experienced that, and back then I was already a senior, so I was already quite protected compared to a junior, so I could stand something. And there was one component that was really core to the system, and so any change to the component had to be reviewed by the chief architect. Now, that person was particularly bad at written communication. And that led easily to blaming, and well, it really pissed me off. And at some point, my colleagues were telling me, yeah, but they are a nice person, you know. Yeah, well, can be, but I haven't met the person and I absolutely dislike them. And, well, I guess, well, I'm afraid the organization lost some engineers because of that behavior. Now, code review should also not vary in content based on who wrote the code, because there is a bias problem in there that can lead to disproportionate harm, and this leads us to code review should not be blaming or harming. If there is no mechanism in place to curate or to train code reviews, it is unlikely that the process will be free from any abuse and bias. So, as a reviewer, well, we should listen, we should reflect on the code without judgment, without harm. And we should lend a willing ear to allow others to do a better job at solving the problem. If we cannot do that, we should not do any code reviews at all. Finally, it should not be a miserable experience. So if we avoid all of the 3 others, well, that's already an improvement. Now, code reviews should also not be gatekeeping. So research is clear about this. Gatekeeping is well, is negatively correlated with quality. It also delays feedback, and it introduces lots of other problems. And lastly, it should not be a must. It's an option. It's a choice the team makes whether to run code reviews or not. We are not more mature if we run code reviews, and we are not a bunch of ragtags if we don't. So I've worked for a product organization where with quite high quality expectations, but they decided to not run any code reviews on new functionality. But they did want to have code reviews on bug fixes, because they thought that the chances to introduce faults were bigger when fixing bugs than when adding new functionality. Now, back then, well, the bugs were quite tricky because, well, most of the time they were related to race conditions. And fixing them was quite painful. Took us mostly a day to just reproduce the problem. And this brings us to non-blocking code reviews. So, somewhere in 2012, I was asked to tech coach a fairly novice team in a rather conservative organization, big player in the finance industry. And the purpose of the coaching was to upscale the engineering skills of the team. So the team was novice, not so much from a working experience perspective. Well, they had a working experience ranging from 5 to 20 years. I've already mentioned this team before, last year, when I presented Feature Branching is Evil, because, well, this is the team that triggered, well, this is one of the two teams that triggered this talk. This is the good team. Now, to be honest, I'm quite proud of anything we did back then with that team. And that was possible because we had this amazing team manager who was like really positive, open to any suggestion we made. His take was, dear team, here is the mission of the team, do whatever you want to achieve that, I don't care, I'm going to do the marketing of the team. Well, he never said it like that, but he acted like that. Now, Stefan is also the one that pushed me into public speaking. Thank you for that. Now, back then we used Subversion because, well, team was novice. We thought Git is a bridge too far, too many concepts to learn, way too complicated. Now, because branching in Subversion is quite painful, well, we also decided to use no branches at all. Everyone was committing straight into mainline. And that worked pretty well because we had continuous integration in place right from the start, and team commitment that any change had to be covered by an automated test, preferably a unit test. Now, because the team was novice, well, I wanted to have some mentoring in place, and the team wasn't particularly open to the idea of pair programming. So, well, there is a cultural stretch in some organizations to adopt pair programming, and well, that's fair. And so, the next best thing we came up with was code reviews. All right. Shit. Pardon me. Right. That won't work. Now, because the team was novice, we also decided that all commits had to be reviewed. So every single commit was reviewed. And because we had no branching in place, well, we did non-blocking code reviews. And well, back then we didn't realize that this way of working was actually a performant way. So the only thing we did was apply lean principles and getting to simple solutions, because I'm a simple mind, and whenever that I see a complicated solution, well, you lose me. It's as simple as that. Now, this non-blocking code review was a combination of two key ideas. And the first key idea was to establish a continuous review process, have a set of rolling regular reviews as part of the development flow. So the team had a Kanban board to track the work, and every ticket was a feature, not a task. This was a whole feature. Now the advantage is that it forces us to have small features, to keep the things as small as possible so that the things go fast from left to right. So the feature was a unit of work on the Kanban board, but the feature was not a unit of integration, and that was the commit. And the unit of delivery was one commit or several commits. Now, to ensure code reviews happened, well, we added a to-review column to track the reviews. So whenever a feature was finished, ready for review, well, we would add it to the to-review column. Now, Dave Farley reported that he has seen this before, but it never really worked, because people saw that as gating. And, well, gating is bad. But here this was different, because, well, our code reviews were not gating. The feature growed commit by commit on mainline, but reviews were happening on the whole feature on mainline. Now, to avoid context switching, well, we agreed with the team also that whenever someone finished work, before starting new work or at the start of a new day, well, they would look at the to-review column if anything was waiting to be reviewed. And if something was waiting, well, they would just pick it and review it. And off we go. And so we had a continuous review process in place. And so we had this rolling review happening. We only had one rule in place, and that was that nobody was allowed to review the feature they were involved with in writing. So reviewing had to happen by another engineer. There were no rules in place regarding seniority of who may review whose code. So seniors were reviewing code from seniors and from juniors. Juniors were reviewing code from juniors and from seniors. I wasn't expecting too many commands from juniors, so I was expecting that by seeing the code of more senior people, they would learn. Although I've seen pretty good reviews done by juniors because they ask different questions. They ask outsider questions like the real, why are we doing this here? Why aren't we trying that? And so these are the good triggers for the necessary improvements. If we do not do pull request or we don't do pair or team programming to avoid that unreviewed code arrives on the remote mainline, well, we end up in a situation where every commit, reviewed or not, lands on the remote mainline. So now we have reviewed code and unreviewed code alongside each other on mainline. And so this code is releasable and this code is also not releasable. How do we keep this apart? And what does releasable mean? And this brings us to the second key idea. Stop the code review to be definitive for the release. So we stopped using the code review as a determining factor in defining if this code is releasable or not. So the code review was not a go, no-go decision anymore. Now the team practiced true continuous integration with trunk-based development that later evolved towards continuous delivery with a deployment pipeline. And so every commit that went successfully through all stages of the deployment pipeline and that have been thoroughly tested, well, had the potential to end in production. So the Kanban board and the reviews happened on the feature, but in the meantime, the software growed small commit by small commit, and every commit could land in production. So now we have that unreviewed code could arrive in production, whether the feature was finished or not. Now we could argue there is a risk that bad quality code can land in production. And yes, this is true, and this happened, and this will happen again. But I don't see a problem there, because bad quality is not a bug. So code reviews are not there to catch bugs. For that we have the automated test and the exploratory testing, which is way more efficient and way more effective than code reviews. So the code reviews are there to improve code quality, for knowledge sharing and for learning. Now the team had committed that any change had to be covered by an automated test and preferably a unit test. So we had a fairly good comprehensive set of automated tests that would catch potential bugs. And then we also had exploratory testing in place where team members would test features from each other. And additionally, we also had a fair amount of static code analysis and linting. So in the end, the code that arrived in production worked because the test said so. And so the risk of working this way is not that the code would be buggier, but that we would deliver lower quality code in production. But code quality has not much impact on product delivery, neither on functionality, but code quality has an impact on speed of change. And this is the reason why we want to have high code quality, because high code quality, well, allows us to add new features, introduce new changes quickly, fast enough, and so this reduces our lead time and reduces our time to market. So in the end, this code works because, well, the test says so. But that could be better. But at some point, this is always true, that the code could be better. Code reviews will only reduce the chances of delivering low quality, but it doesn't remove low quality code altogether. But releasing bad code quality isn't the end of the world. The automated test passed, the feature works, and in the end, well, the users can benefit from the feature. And this worked because we had also team commitment that all commits were going to be reviewed, and that whenever an issue was raised during a code review, well, it was handled with high priority so that we could remove the bad quality as soon as possible out of production with the next release. All right, so what are the benefits? Well, before we can understand the benefits, we need to first understand transaction cost from manufacturing. So the transaction cost is the cost of sending a batch to the next stage. Now this is important because, well, the higher the transaction cost is, well, the more inventory we will create in front of the next stage to compensate the transaction cost. So if, for example, we want to buy some goods online and the transaction cost is €3, so it costs us €3 to deliver the goods, well, it doesn't really make sense to just buy one good of €1, does it? No, what we are going to do is buy several numbers of goods so that we get to a multiple of the transaction cost so that we can compensate the transaction cost. Well, the same is true for software changes. If it only takes us 10 minutes to introduce a change and we have blocking code reviews and it takes 2 hours to get a review, well, that change was waiting 92% of its total lead time. This is a pretty expensive process, does it? Yeah. And so it signals us that code reviews are fairly costly. And so it incentivizes us to ask less often for code reviews. And so what happens when we ask less often for code reviews? Well, we will make more changes before asking for a new code review. And so the process discourages us to work in small incremental steps, and it discourages us to make small changes, and as a result we will do less refactoring and we will do less incremental development. And because of all the waiting that is happening, well, people don't like to wait. Well, they feel uncomfortable to just wait and do nothing, and so they want to be productive. And so what happens? Well, people will start new work while waiting, and there you go. We have more work in progress that is created, and we also start introducing context switching. And we know where this goes, and it's not pretty. Now, because of Little's law, work in progress has a significant negative impact on total lead time. So the higher the work in progress, well, the more delay we incur. And so we get delayed delivery, delayed feedback, learning will decelerate, and we will become more risk averse. And so, well, innovation will fall flat, and we will go back to conservative solutions. So, In order to get things out sooner, we need to minimize the transaction cost. And so we need to reduce the cost of a code review in order to reduce work in progress, reduce lead time, and accelerate feedback. And this brings us to the benefits again. Because the transaction cost is nearly zero with non-blocking code reviews, well, it's nearly zero because there is zero impact on total lead time. So the code review doesn't block the delivery. We create the code review, but in the meantime, commits are just going through the deployment pipeline into production. And so there is no reason for people to stuff more work into bigger batches before asking for a code review. And so this incentivizes to work in small increments, do lots of refactoring, and in the end we will obtain higher quality, and higher quality means we are optimizing engineering time to introduce new functionality. So this reduces time to market and reduces cost of delay. Because we are never slowed down, well, we never block the delivery. So we commit and we commit and we commit, and every commit goes through the deployment pipeline. And every time it goes successfully through the deployment pipeline, it has the potential to go into production. This also allows us to receive early and fast feedback, and so we can take more decisions, and we can run more experiments, and we can then find more ways to delight our customers, which is a huge competitive advantage. Now, the fact that unreviewed code could land in production was surprisingly a significant benefit that I only realized when writing the article, because now we get early feedback from testing and from production before even having received any reviews. And so we could see how the feature was used by users, if it was used by users, and if there were code review issues raised, well, we could use this feedback to do a better job at fixing the problem. Thanks to the non-blocking code reviews, well, it also avoided that new work was started before other work was finished. So people could work on a feature from start to finish. They never had to wait for someone to be available to perform a code review and thus to be able to continue their work. And so they were never incentivized to just start new work. And so as a result, well, we had less work in progress. And because we had less work in progress, because of Little's law, it reduced our lead time. And so we had shorter times to market. And again, this means we have way faster feedback, more feedback. And again, we could take more decisions, run more experiments, and find more ways to delight our customers. And in the end, it means generating more money. Sometimes it happened that during a code review we spotted that a design was completely off. Like you're like, oh damn, this doesn't look good. These were times where I was like, I wished we did pair programming to avoid the situation and so to minimize rework. But in hindsight, this wasn't really a big deal, apart from wasting time, because, well, no one was waiting for this redesign to happen and this rewrite to happen, because, well, the feature, well, passed all tests, was working, delivered value for our users and was used by our users. So we had all the time to redo the design and to rewrite the code. So there was no pressure. If we use blocking code reviews like pull request, well, we don't have that option. Well, we have two options, actually, if we spot a bad design. Either we say, no, we need to fix it, but we don't have feedback, and users don't have the feature as long as it hasn't been fixed, or there is lots of pressure to deliver, and then we cut corners, or worse, we decide to not fix it, and this is the start of technical debt. So here we have no pressure, no stress, no fatigue, no burnout. You really want to keep the schedule. Good. Because unreviewed code could land in production, well, it also put a high trust on the team. So we were expecting they were going to do the right thing, instead of thinking they were stupid and that we needed a process to fix for that. No, we were expecting that the team would add enough tests and would add the right tests. And even if something went wrong in production and that something broke in production, that wasn't really a big deal because we had continuous delivery in place that allowed us to fix these problems quite quickly, so in a couple of hours. Now, many times people ask me, yeah, but what tooling did you use to do the code reviews? Because, well, the problem is current tooling for code reviews are all pull request based. All vendors discontinued their tooling in favor of pull request. So back then we used Atlassian Crucible. So Atlassian Crucible essentially is a database that collects the commits from the version control system. So we asked the team members to tag all commits with the feature ticket number. And then when the feature was ready for review, well, they created a review and searched for all the commits that were linked with the feature. And here you have your review. JetBrains back then also had a similar tool called UpSource. It's discontinued. Facebook had Fabricator, it's discontinued. We have Garrett, which is quite interesting. Horrible UI, but it does what it needs to do. It was designed by Guido van Rossum, the creator of Python, for the Android teams at Google. So the main idea of Garrett is that Garrett is a Git repo in front of the main repo. So engineers pull their changes from the main repo and push to Garrett. And then there, the commits are waiting to be approved, and once they are approved, they are pushed to the main repo. Now, from my understanding, there is still a blocking of commits that is happening, though some people told me, yeah, but no, you can use it differently. So, well, I need to have another look at it, so I don't know. Recently, I've met someone from Auctionit, and he shared with me, oh yeah, we're doing string-based development like for more than 10 years. Oh yeah, I know the problem with code reviews, tooling is not available. So we started implementing our own code review tool, and this is Xremit. It's open source and it's available on GitHub. I've never used it, so I can't say if it is good or not. And then I've recently discovered ReviewBoard, which seems to be similar to Crucible. And then one of the reviewers of the slide deck said, yeah, but wait a minute, we don't really need tooling to do this. We can also have just engineers projecting the code and guiding the team through the code and just discussing the code. So this works also. All right. Well, to be honest, there's one gotcha with non-blocking code reviews. It might be difficult in regulated industries. Many regulated industries require code reviews, and production releases are blocked by go-no-go decisions that are defined by the code review. So in that case, non-blocking code reviews won't work. However, there is a way better way to implement this way of working, and this is using pair or team programming. So if we are pairing, well, the pair can sign off the review at the minute they want to commit and tag the commit with the IDs of the engineers. All right, in conclusion, I still think pair programming and team programming are way better ways of working. It's far more efficient. But there is a cultural stretch for some organizations and some teams to adopt that, and that is okay. In that case, I think that non-blocking code reviews are significantly better than all the alternatives, because there's no gating. And because there's no gating, we don't have delays we don't have delays of delivery. We can maintain the fast flow of work through our value stream, which is critical to obtain better quality. Because there are no waiting times, well, team members are not incentivized to start new work, and so we have way less work in progress. And because of Little's law, well, our total lead time is reduced, our time to market is reduced, and we have less cost of delay. There's also no context switching because we don't have so much work in progress. So team members, well, don't start new work, no context switching, so no multitasking, no productivity killer. There's also no urgency to fix code quality issues. We have all the time to do that, and so we are able to do a better job at it, and so we are able to deliver way better code quality. And it allows us to grow our features incrementally, small commit by small commit on mainline, and this allows us to work in small incremental steps and do incremental software engineering, and this also allows us to do more refactoring than would be possible with other ways of working. And so, well, again, improved code quality, optimized engineering time, shorter lead times, and shorter times to market. All right, thank you.